Okay, so we're going to be talking today. I'm going to be talking about it today about the Earth's dimensions and the shape of the Earth and some of the characteristics of the Earth. And the Earth itself is what's called an oops, it's called an oblate spheroid. Um, it's a it's a shape that is not a perfect sphere. It's a little bit squished at the poles and bulging out in the middle. And that has to do with the way that the Earth is rotating. So as the Earth spins, the the middle tends to want to is moving faster, and so it has more force on it, and it's pushed out sort of out towards space, and so we get this bulging, a little bit of a bulge towards the equator. And now I want you to be careful when I say this, because I don't want you to think that if you look at the Earth from space that it's very obvious that it's bulging. The Earth looks almost perfectly spherical, but when we take very delicate measurements and very specific measurements, it does bulge slightly in the middle. So how do we know this? How do we know that the Earth is round? And this goes way back to ancient astronomers trying to figure out how the Earth was shaped, and that the Earth wasn't really flat. And all the next slides that I'm going to show you are going to go under the evidence part of your notes. And the evidence, one of the pieces of evidence, if you look, this is a little ship. This little ship is sailing out to sea. And as it goes further out to sea, if I were to look at it through a telescope, it might look like this. And what I want you to think for a second, what you think will happen is that that ship goes further out to sea. What happens to that? Well, what happens is that it appears to get lower and lower in the water until it's completely gone. And so it sinks slowly as you go further out. So ships disappear past the horizon, over the horizon, and they appear to go from the hull, sinking down through to the top of the ship. And that the example that I use here, the CN Tower, my parents live near Lake Ontario, and when we go to visit them, if I take some binoculars out, I can actually see Toronto from the edge of Lake Ontario. And all I see though of Toronto, if the sun is setting, I can see a silhouette of just the top of this tower, and that's because the Earth is curved, and as you get further away around that curve, it appears that everything sinks down or is below the horizon. So ancient people would go out to sea, they'd sail away, and it would look like their boats were sinking, and then as they came back, they would rise up out of the water. So that was early evidence. We also, ancient astronomers, also were able to see that the Earth's shadow during an eclipse, during a lunar eclipse, we see the shadow go across the moon and come back. So we can see the whole shape of the Earth as a lunar eclipse occurs. And I decided to just give you a brief, pull up a brief animation of this. You can see as the moon passes into the Earth's shadow, you can see the shape. It's curved, and we can actually, by knowing the distance from this is the full shadow of the Earth. There's two sort of shadows that cross, where the moon is partially eclipsed here. It's not fully eclipsed, and as the moon goes through through the eclipse, the moon gets darker, and then it comes back into the lighted portion. And now it's coming out of the shadow, and you can see the shape, the curve of the shape of the Earth's shadow. So that was another way that astronomers were able to see that the shape of the Earth. More evidence. There's time differences between different places. So if we look up in the sky here, we'll see the sun rise much earlier than in California. So the sun rises later in California. That's why we have time zones, so that we can not be in the middle of the night and have it be 2 p.m. So we have these time zones. There's time differences. There's something with that has to do with this altitude of the stars change. So Polaris changes as you go from one place to another on the Earth, and we'll talk a lot more about Polaris. So if you're not sure what Polaris is, it's the North Star. We'll talk more about that. And it can't be seen in the southern hemisphere. So when you get to the southern hemisphere, we can't see some stars that we can see in the northern hemisphere. So if the Earth was flat, we should be able to see everybody should be able to see the same stars. And finally, when we were finally able to get into space and take pictures, we could see that the Earth was round. That was one of the basic things. And if you look, there is no big bulge here. So the bulging of the Earth is very, very small based on the Earth's rotation. So when you look at the Earth from space, it looks like a balloon, or sorry, not a balloon, but a basketball or a beach ball or a marble or any other kind of ball. Sorry, had a little. So when we look at the moon or the Earth from the moon, we see that as well. That's sort of the basics of when we're looking at the Earth and its shape and how we know that. Now we break the Earth up into these three different spheres. We call one is the lithosphere, one is the hydrosphere, and the other is the atmosphere. The biosphere you studied last year with biology. The lithosphere is the solid part of the Earth. It includes the crust, the upper mantle, bedrock, continents, the ocean floor. It doesn't include the oceans, but there's rock underneath that, those oceans. So it's the ocean floor. The hydrosphere is the water part of the Earth. It contains the oceans, lakes, rivers, groundwater, glaciers, any of those things that have water in them. So the hydrosphere is the liquid portion of the liquid water on the Earth. It is about 75% of the whole Earth in terms of its surface area, not in terms of its volume. The lithosphere is the solid part, so it goes much deeper and it's much bigger. And then last year you guys studied the biosphere. Biosphere is just all the living things on the Earth. And then we will also study the atmosphere, the shell of gases that surround the Earth. They're divided into layers based on composition and temperature, and we'll talk more about that when we get into the atmosphere. And the troposphere is the layer closest to the Earth. It's the most important layer. It's the one that contains everything that we need for life. It contains most of the water that we need. And all of these things, even though we divide them into different groups, they all work together. They're all interconnected. So the lithosphere affects the biosphere. So certain living things can only live in certain areas because of the soil type. The atmosphere in certain areas affects living things. The atmosphere can affect the types of rocks that are formed. The hydrosphere can affect the atmosphere. Water vapor goes into the atmosphere. The hydrosphere can affect the lithosphere, which kind of rocks can form. And obviously we need water for living things. So all of these things are interconnected, and the biggest source of energy that comes into the Earth system is from the sun. So solar energy is our biggest input, and then all these things are are affected and interact because of that. So I hope that makes sense, and if you have any questions, feel free to write them down and we can talk about them in class. Thanks.